Need to track requests across services, or add context to your MCP tool calls without cluttering the main arguments. You'll see how FastMCP's meta parameter lets you attach trace IDs, source identifiers, or any ancillary data to tool executions, while keeping your core arguments clean. The pattern works for observability, debugging, or even feature flagging, all without modifying your tool's input schema.
Async with client. Result equals await client call tool. Name equals send email. Arguments equals to user@example.com. Subject, hello. Body, welcome. Meta equals traced, ABC 123. Request source, mobile app.
This demonstrates the metadata-augmented RPC pattern, where tool execution combines primary arguments with ancillary context data. The approach cleanly separates functional parameters from operational metadata, enabling cross-cutting concerns like tracing, source identification, and observability without polluting the core business logic. What makes this distinctive is the explicit dual-channel design. Arguments carry the functional payload, while metadata provides execution context. The pattern works by establishing parallel data streams within a single call. Primary arguments flow through the standard RPC channel for tool execution, while metadata travels alongside as a separate but synchronized payload. This maintains clean separation of concerns. The tool implementation focuses solely on its core task, while the framework handles metadata routing and processing. Servers can then use this metadata for logging, access control, or request correlation without requiring changes to the tool's interface. This approach solves the common problem of mixing operational context with business data in RPC systems. By formalizing metadata as a first-class concept rather than an afterthought, it enables consistent observability across all tool calls without requiring individual tools to implement logging or tracing. The trade-off is minimal, just a few extra lines in the client call, while gaining enterprise-grade request tracking and debugging capabilities out of the box. It's particularly valuable in distributed systems where requests span multiple services and need consistent correlation identifiers. Let's break it down line by line.
Async with client.
This establishes an async context manager for the client connection. It guarantees proper resource cleanup when the block exits, preventing connection leaks. The pattern is essential for managing async resources like network clients.
Result equals await client call tool.
This invokes the AI callable tool named send email asynchronously. The await handles the async operation, ensuring the calling code waits for completion while allowing other tasks to run concurrently. This is the standard pattern for executing FastMCP tools that perform I/O-bound operations like email delivery.
Name equals send email.
Specifies the tool name as send email, which uniquely identifies this callable function in the FastMCP system. This string must match exactly what the AI model expects when requesting tools, ensuring proper routing to the correct implementation.
Arguments equals.
The arguments dictionary defines the tool's input parameters, mapping parameter names to their values. This is the standard pattern for passing structured data to AI callable tools, ensuring type safety and explicit parameter naming. The keys must match the tool's declared schema exactly.
To user@example.com.
Specifies the recipient email address for the send email tool. This is a required field in the tool's schema, ensuring the email has a valid destination before dispatch.
Subject, hello.
This sets the email's subject line to hello. Required field in the email tool schema, It defines the purpose of the message and appears in the recipient's inbox preview.
Body, welcome.
This defines the email body content as a plain text string. In FastMCP tool calls, this becomes the body field in the tool's input schema, ensuring the AI or calling system knows exactly what data to provide. Closing dictionary syntax. This terminates the meta dictionary and completes the tool call arguments, ensuring all metadata is properly encapsulated before execution.
Meta equals.
The meta parameter passes non-functional metadata to the tool call. This enables tracing, logging, and analytics without affecting the core email sending logic, keeping operational data separate from business data.
Traced, ABC 123.
This is a distributed tracing identifier. The traced links this operation to related logs and metrics across services, enabling end-to-end request tracking in production, critical for debugging and performance monitoring in distributed systems.
Request source, mobile app.
This metadata key tracks the request origin, enabling source-specific handling, critical for analytics, routing decisions, and debugging when the same tool is called from multiple platforms. This closing brace terminates the meta dictionary, finalizing the tool call's metadata configuration. Metadata like traced enables request tracking across services, while request source helps route and analyze traffic patterns. Closing parenthesis terminates the client call tool invocation. This finalizes the async RPC call, sending the complete request payload including arguments, metadata, and tool name to the FastMCP server. The context manager ensures the call executes within the established client session. FastMCP tool metadata pattern. The meta parameter in tool calls creates invisible channels for contextual data that never touch the tool's core logic, yet shape how clients interact with it. Metadata keys must be strings, and values must be JSON serializable to ensure transport compatibility. This separation of concerns lets you evolve tracking and routing logic without modifying tool implementations.
The metadata that carries no meaning becomes the only meaning the system understands.